Well, welcome back. However, today we're not in the arcade. We're here at my computer because the next thing I want to do is test the two RAM boards, which I suspect they have bad RAMs. And the only way to do that is to burn a test ROM so that we can find out if any of the RAM is actually bad, and should tell us the location. But before I do that, and I didn't want to use my board that's in the game now. I wanted to use the one working spare board that we tested and found was working, and that's board number 13. However, this board here, I think it's strapped for well, let me back up here. The ROMs on some of the boards, the original ROMs were mask ROMs. In other words, they were, once you program them once, they can't be programmed again. And a programmable ROM, you can reprogram them, erase them and reprogram so many times. But this particular board is strapped for mask ROMs, yet they replaced 3 of the mask ROMs with regular programmable ROMs, but they used 2532s, I believe. Let's see. Yeah, 2532s. Okay, in order to get the 2532s to work with the board strapped as mask ROMs, they went ahead and made a modification to the ROM here. They lifted one pin and ran a wire from that lifted pin to the pin on the edge right here. So it's a modification that you have to, I don't know exactly how it is, I haven't looked into it, but you have to make a modification in order to use these for a board that's strapped for the mask ROMs. So my original board is already strapped for 2532 ROMs. So what I want to do is I want to change this board, and I'm going to burn a new set of regular programmable ROMs, 2532s, and put a new set of ROMs in here. But in order to use that, I'm going to have to restrap the board. Now, to restrap the board, you have 3 sockets here. You got X31, X32, and X33. And they're just regular, like IC chip sockets. And it uses 2 of them use a 16 pin. Well, they all use a 16 pin, but these 2 right here have, they're a little bit longer. They got, the last part here is open, so that they just put a regular short, whatever you call that. I guess I'll call that a strap, because on the in the manual they say it's a strapping chart, which tells you how you strap it. Now, let me show you. Most of my boards have these in them right here. I don't know if you can see it. This fits in like an IC chip, and just plugs right into the chip. And right on the top, you have little pieces of wire that jumps across the 2 leads on the chip. Some of them are connected and some of them are cut. So depending on which ones you leave connected and which ones you cut, that's called strapping the board. In other words, it rewires the circuit so that the particular ROM or mask ROM that you put in here has the correct pin out so that it works with the board. So anyway, once you cut these, this type right here if you change it, you might have to reconnect one of these that's been cut. So as you can see right here, somebody's already done that on this one. They put a glob of solder across it to reconnect them. And this one's the same way. Okay, well, you can do that with these, but this board right here has a different style. And I don't know if you can see it on camera, but this has a piece of, I don't know what it is. It looks like just a solid piece of metal that runs across here. And it's not cut. None of them are cut. So I was thinking, how in the world, you know, do you open it and close it? So I went ahead and pulled one of them out. Let me pull one out and show you. And it's basically just like an IC chip, and it's got the legs on it here. Well, one side, all the legs are here, but on the other side, the ones that has to be open, they didn't cut the legs off of them. So only the ones that make a full connection have the legs on them. So that's how they strap this particular type, is by taking a clipper and just clipping the legs off. Okay, so where do you get these things? I don't know. Maybe somebody has a source for them and knows where you can get them, but I don't. So what I'm going to do is take a machine pin socket. Now, I know a lot of people don't like machine pin sockets. I kind of like them myself, but most people like to use double wipe socket. But anyway, if you take a machine pin socket, here's a stapler. So I'm going to show you how I did it. Take a staple. Now the staple is too wide to fit in the slots. So what you have to do is you have to bend it on one side to the right distance so it will line up with the holes in the chip here. And then you have to take the clippers and clip it to the right size. So let me show you how I do that. So I'm going to try to show you how to make this. We're going to take a stapler. Let me get a staple out. Now we'll take a pair of hemostats. And I'm just going to take a guess, clamp it in the hemostats. Then you can take it and sort of eyeball it to try to get the bend so that it'll line up in the holes on the chip. Need to adjust it just a little bit. All right, let's try that. Okay, that might be close enough. Now we'll just take and bend it. Put that 90-degree bend on it right there. We take and cut that part off. And we shorten the leg up on this side. Now we just clamp it in the middle here. Now if we look at our strapping chart here, I've already made X31 and X32, so now we're going to make X33. So X33 pin 1 is closed. So this is going to close pin 1 to the adjacent pin. So what we need to do is just line them up into the chip, unclamp it, and then just push it in like you're putting a chip in. And there you have it. First to the strap. So So now I got to do this 3 more times because X33, well, all of them have 4 closed circuits and the rest are open. The first one is closed, the third one is closed, 6 and 7 is closed, and the rest of them are open. So let me do this 3 more times, and then that'll finish that up. All right, I'm gonna try this 1 more time. See if I can get this in focus. First, we'll get a staple out of the stapler. Then we take our hemostats and we just eyeball it. And what we've got to do is make a 90-degree bend so that that bend we put in is going to be the same distance that's between the holes in the machine pin socket. So we're just taking, eyeball it and try to get it so when we make that bend, that leg is going to line up with the machine pin socket spacing. I think it needs to be just a little bit more. Okay, we're going to try that. So we're just going to make a 90-degree bend. I think that's looking good. And we're going to take our clippers here, side cutters, and just clip that leg off. And clip the original longer leg off. Now I'll just clamp it right in the middle here. And let's see, our next strap is going to be, we got one on 1 and 3. Now we go down to the 6th one down. So 1, 2, 3, 4, 5, 6, which is right here. Need to bend it in just a little bit. Okay. 1, 2, 3, 4, 5, 6. Okay, that got it started. And then we just press it in. And there we have it. One more strap to go. So maybe that one looked pretty good and a little bit in focus. So let's do the last one and then we'll put them in the board. Okay, got my newly made ROM straps in the board. And I took the old ones out and I labeled them, so if I ever need to put them back into a mask ROM board, I'll have them and I'll know which one goes where. I won't have to look it up. I just have to put them back in. Okay, now all I have to do is remove these ROMs out of here and put a fresh burned set of ROMs in, and this board will work because this board was tested good. So then I can burn the test ROM, and I believe the test ROM goes right up here in this position right here. Then we'll be ready to test the RAM boards. Okay, well, let's go ahead and finish burning these ROMs. I've already burnt ROMs A through G, so I got 2 more to go. So I figured I'd show you how I burn ROMs. This is, I probably had this 20 years at least. This is the N-Tronics, the Pocket Programmer. Now this is the older version that works with a printer port or a parallel port. Not many computers nowadays have printer ports or parallel ports. As a matter of fact, I don't think none of them do. And from what I understand, this will not work in a new computer with an add-on card for a printer port. I think you can get cards to put in a modern computer that would add a printer port, but I don't think the timing is right. So, and it doesn't work. Now, the Pocket Programmer, I think they're still in business, at least the last couple of years when I checked. I think they may have changed names, but I think they're still in business, and they make a USB version that plugs into a USB port. But this still works, and my old computer still works, so why upgrade? You know, why fix it if it ain't broke? So, with that said, this is my EEPROM eraser. This is a Data Race 2. And this one has an on-off switch, and it has a timer where you can set up to, I think it's 24 minutes. And I think I got this set on something like 15 minutes. But sometimes you need a little longer, so sometimes I do them twice. I could just turn it up to 24 to full, but you know, it depends. So the way this works is it slides open, and this will do 4 EEPROMs at a time. I just erased this one because I had another program on it. And the way it works is it's got a little switch here somewhere. You can't turn it on with the door open. It has the ultraviolet tube right here. You can see the tube right inside these windows, which is what erases the window of the EEPROM, because the ultraviolet light that comes out of here is bad for you. It's bad for your eyes especially. So it will not turn on with the door open. The door has to be closed before it'll actually turn on. So that's how I erase my EEPROMs. So now we'll just put it in the programmer. And we'll go to my program here. See if I can zoom in on that. This is a Windows version, so it does run under Windows. And again, I don't know if I can get it to focus or not. I think that's focused. So, the way this works, you have to load the buffer. So you click this, and this is my directory on the computer that I have the files. And let's see, I've done G, so one more to go, H. So we'll choose H, GORF H bin file, and we'll click to open. Okay, now it's programmed into the buffer. So now we'll go up here and do a blank check. And it says our device is erased. So then we go up here, program device. So we hit that. And it programmed, and it says device verified to buffer. So that means it's compared what it just programmed into the EEPROM with the contents in the buffer, and it matches. So, and if you want to, you can, let's see, go down here and do program compare. Well, no, verify device if you want to verify it again. And I just checked it again. It says device verified to buffer. So we're done. This chip is programmed. So Now I'll just take one of my little stickers and I'll line it up over the window. See if I can get it straight. That's pretty straight. So then I'll just write GORF. And this was H. And there we have it. Completed set of GORF ROMs on 2532 chips. So now we can go ahead and pull these chips and insert them on the board, and then this board should be ready to go. Okay, there we have it. GORF board, all new ROMs, all new straps, all ready to put it in the game and check it out. Okay, well, the next thing we're going to do is we're going to burn this test ROM, which allows us to test the RAM board to find out if we have bad RAM, and it's supposed to tell us the location of the bad RAM. This test ROM, I believe there are a couple out there, but probably one of the better ones is the one that Mark Speth put together. And I don't remember where I got this from. I guess he posted it at one time. So anyway, usually these files come with a text document, and this is the text document for it. And this says GORF Complete Memory Diagnostics 2006, Mark Speth at speth@gmail.com. This test ROM exercises the SRAM and DRAM on a GORF board set and identifies bad chips. The code requires that the Astrocade custom chips are working, that's the special chips on the board, in order to perform magic screen writes, but does not use the pattern board. Future versions may exercise and or test the pattern board, but this version does not. Only the first bad chip detected is identified when the RAM test is run. But if multiple chips are bad, multiple passes may identify multiple chips. The code uses 32 pass pseudo random write and read back test, which is much more robust to different kinds of errors than a simple walking bits or pattern test. This test is similar to what Namco uses in its games. The code was painfully written not to require any RAM space to be functional for proper execution. Example, no variance or stack space is used. The included binary image should be padded with 0xFFS and may be burnt into a 2716, 2732, or 2532, depending on how your ROM board is configured. In any case, the test ROM should go in X1 at address 0x000. Most of the screen font was borrowed from Dave Turner's video RAM diagnostics, which sadly failed to detect several kinds of RAM errors that I encountered on my boards. But the rest of the code is original. Suggestions, PayPal donations are welcome at mspith@gmail.com. At the current time, 2006-8/8. I do have most of the pattern board documented, but I haven't written any test code for it. This may be included in a future release, since I have several dead pattern cards to test. But there'll be more hands-on rather than self-diagnostic like this code. So that's the message that is the text document is embedded with the code. And the code is gorftest.bin. So now we'll go ahead and program the ROM. Okay, first I'll get the ROM, which I erased, and we'll put it in the Pocket Programmer. And now let's go to the computer screen, to the program, and go ahead and we'll program. Okay, well, we got the erased EEPROM into the Pocket Programmer. So now we go and first we can do a blank check to make sure it is erased. And it says device is erased. So now what we have to do is we have to load the file from the hard drive into the buffer. So we hit the load buffer. Now we have to find the directory that the file is in. So should have a GORF file. And here it is, gorftest.bin. So we click on that, hit open. Now that file is loaded into the buffer. So now all we have to do is go up here and hit the Program Device button. And bam, device verified to buffer. So it's all programmed. But we can check it again if I want to. We can hit the Verify Device button. And it verified again to buffer. So that means we have now programmed the ROM. So now we can take it out of the Pocket Programmer and we can go out to the game room and we can use it to test the RAM and the RAM cards. Okay, well, we're back in the arcade, back to the GORF. So, as you can see, GORF is back up and running and making noise. So, I'm going to go ahead and turn them off. And what we're going to do now is, I just finished burning a new set of ROMs and restrap this board. This board was working when we tested it. So, but I went ahead and removed it. Had a combination of mask ROMs and modified, let's see, what are these? 2532s. Had 3 modified 2532s where it had a leg lifted and a wire run between the lifted leg and the end pin here. So it was, they didn't have to restrap it and didn't have to replace all the mask ROMs, just the ones that were bad. So I went ahead and, as you've seen, I've made these strap jumpers here. So hopefully this board is going to work. So let's go ahead and remove my original board that's in the game here. this is basically the same board. The only thing I did notice that these two boards are different, and I did kind of investigate it a little bit. I believe this is the U.S. board, and this is the overseas foreign board, because it doesn't have the ROM sockets are arranged differently, and all the ROMs are on the top right here. So, but it still works. So it doesn't really make any difference. Okay, well, we're going to put this board in now and see if it works. Okay, moment of truth. Let's turn it on and see what happens. Well, that's a good sign. Let's see if we get a picture. Yep. Game's booted up and seems to be running fine. Let's see if it goes into the attract mode. Okay, well, it looks like my ROM burning and okay, GORF, that's enough. It looks like my ROM burning was a success, and my restrapping, my homemade restrapping, whatever you call those things, works just fine. So now what we can do is we can pull the A chip right here and replace it with the test ROM. Then we can put our bad RAM board in here and see if it'll tell us if we have a bad RAM or not. Okay, well, I'm going to end the video right here. In the next video, we should be ready to put that test ROM in and go ahead and test those two RAM boards to see if we have bad RAM on, and see if it'll tell us where it is on the board. And hopefully we can go ahead and get those two RAM boards squared away and repaired and back up and running again. So I hope this video was informative to some of you. I know a lot of you that's been in the hobby like myself for a while, this is just old stuff, but it's a lot of new people out there into the hobby, or people that is wanting to get into the hobby. And well, maybe I hope that this video, or this type of video, might give them a little bit of insight as to how all this works. It's not a big mystery. It's not that hard. And if you go ahead and get dedicated to it, anybody can do it. So I hope you enjoyed it. If you do, hit that subscribe button and you'll be notified when the next video is released. Until then, this is just another arcade fix. Have you had your arcade fix today?